Jakub, Fabian, all yours. Thanks.
Hi, hello. Today we will tell you about migrating virtual machines from oVirt or VMware to KubeVirt. And we are Jakub John, Senior Software Engineer at Red Hat.
And Fabien Dupont, Senior Principal Engineer and Engineering Manager, also at Red Hat.
Okay. Sorry about that. And the agenda for the presentation is as follows. For starters, I will introduce the virtual machine import operator. And afterwards, I will demo an actual virtual machine import from oVirt to KubeVirt. I will explain what the virtual machine import operator is and how it can be used. The virtual machine import operator part will end with a demo of an alternative, a manual way of transferring your oVirt VM to KubeVirt. After all of that, Fabien will introduce you to the Konveyor's Forklift, and he will show you how it can be used to import VMware virtual machines to KubeVirt. We will wrap the session with a short summary and answers to your questions. Let's have a look at the virtual machine import operator. The virtual machine import operator is a Kubernetes operator that is able to import compatible KVM and VMware-based virtual machines into that cluster, where they would be run by KubeVirt. Saying compatible is important. Not all options that are available in vanilla KVM hypervisor are available in KubeVirt. The operator takes care of checking the source VM configuration and reports its findings to the user. Let me walk you through the VM import from oVirt to KubeVirt. For the purpose of that presentation, I've created a virtual machine in my oVirt cluster. Inside the virtual machine, we need to make a note of virtual machine ID. We'll need it to import it. The VM has one network interface that is connected to APS network, and the profile name is also APS. That virtual machine has one disk, which hosts Fedora Linux, and it's a bootable disk. We can connect that virtual machine now, and we can leave a certain message to ourselves for the future that we can read on the Kubernetes side while the machine is running under KubeVirt. We'll create a simple text file in our home directory. Yeah, that's it. And now I will show you the manifest that we need to prepare to run the Kubernetes secret, and that contains information about our oVirt cluster. It will be created in, it should actually be created environment in your application's namespace. So inside we provide API URL, username, password, and CA certificate that we'll use to validate the connecting to. The other file we need is the virtual machine import CR that will reside in the same namespace. It references the secret I've just shown you. It will use it during the import. And inside the specification, we provide the name for our virtual machine in KubeVirt. We define whether that machine should be the import, and we provide the ID of our oVirt virtual machine by putting here. Also, for that virtual machine, we need to provide mapping of its resources like storage. In this case, we map our data to a storage class in Kubernetes that's called standard. In case of network, we map our network pod network in Kubernetes. Let's create those resources in our cluster. And right after creation of our virtual machine import resource, the import should kick in. Let's have a look at the status of our CR. There we have two status conditions already present that tell us that the validation has been completed. And there were some warnings reported that do not block the import. Also, before copying the disks, the virtual machine has been stopped in our oVirt source. Right now, it's in progress of copying the disks. We can have a look at the data volume that's been created for a virtual machine and monitor it for progress of that part of the import. It will take some time because the virtual machine's disk is pretty big, but as you can see, it's done. And we can now see what effect does it have on our virtual machine import CR. We can see that there is a status condition saying that the virtual machine is ready and the import was successful. We can have a peek at our virtual machine instance. We can see that it's running, it's connected to a pod network, and we can connect to that as well with VNC to confirm that it's the same virtual machine that we wanted to migrate. Again, we'll have a look in our home directory, looking for our hello file. It's there. And the content matches what we had on our site. Let's move to discussing what made that functionality actually work. Virtual machine import operator comprises of two single container pods, VM import controller and VM import operator. The VM import controller pod is responsible for executing the VM import reconciliation loop, while a VM import operator's responsibility is managing the lifecycle of the VM import controller and all related resources like CRDs, service account role, deployment, and services. Let's have a look at the environment of the VM import operator and its collaborators. As mentioned earlier, the operator is deployed in a Kubernetes cluster in two pods. It reads or creates cluster objects like secrets, config maps, storage classes, pods, or network attachment definitions. The operator creates virtual machine objects which are supervised by KubeVirt. And containerized data importer, CDI, in turn, is used to transfer disk images to Kubernetes storage. The last system that takes part in the import process is oVirt, that manages the imported machine. VM import operator reads metadata of the imported VM, requests its shutdown for the import process, and startup in case of an import failure. CDI, in turn, connects to oVirt to download the disk images and stores them in Kubernetes storage. After the overview of the infrastructural part of the operator, let's have a look at the domain side of it. The virtual machine import is a namespace custom resource that defines the source of the VM, the identifier of the VM on the source, and the mapping to be used for the import. The mapping of resources, network, and storage from the external VM provider to KubeVirt is defined in the resource mapping custom resource. Kubernetes secret is needed to define the endpoint and credentials to the source provider, in this case, oVirt. Let's go over the VM import flow. First, the user creates a virtual machine import CR. Next, the virtual machine import controller retrieves the configuration of the source VM from the source provider, validates the CR and the VM, and stops the VM at the source provider. In the next step, the virtual machine import controller creates a diskless KubeVirt virtual machine. Afterwards, the virtual machine import controller creates a data volume CR for each VM disk in the source VM. Based on that, the CDI controller creates the PVC using specified storage class, and spawned importer pod connects to the source disk and streams it to the persistent volume. In case of VMware, there is a need to convert the imported disks using Virt v2v, and that job is executed by a conversion pod. Finally, the new virtual machine is started if the source VM was running or the user instructed the operator to start it. The virtual machine import operator uses public features of KubeVirt and CDI, and VM transfer to KubeVirt can also be performed in a completely manual manner, but lacking validation, error handling, and recovery that are provided by the operator. Let's see how that can be done. To perform, let's say, manual import of a virtual machine, we need a config map that defines C certificate of our oVirt server. We need specification for our data volume that will host our VM's disk. In this case, we need to provide reference to our config map, ID of a disk in the source provider, reference to a secret that I will show in a moment, and URL to our oVirt engine. So let's create the resources we need. The config map, and now we'll create a secret that will contain user and password for accessing out of your oVirt cluster. When we have these two dependencies, we can create the data volume, and we can monitor the progress in a similar way as we did with the automatic import. When we have the data volume in the cluster, we need to create our virtual machine and reference our disk in there in the volume section, and then specify that volume as a disk of our virtual machine. And if we have a virtual machine with many disks, we need to create that many data volumes for manually to import those contents. We've created the virtual machine, and it's running. It's got an instance. It's connected to a network. And again, we can connect to it with VNC and confirm that it's exactly the same virtual machine as previously and as in the oVirt cluster. We'll look at the file, which should be called hello. It is there.
Thank you,
Fabian.
So let me share. Okay. Just quick confirmation. Do you see my screen? Thank you, Jakub. So now that Jakub has explained how to migrate just one VM, let's go over the concept of Forklift. It's we have created a community called Konveyor that is focusing on helping people modernize and migrate workloads to Kubernetes. The idea behind that is it should be easy to do a migration since we know exactly the technical aspects. So we're creating many tools, and one of those tools is Forklift. Its goal is to help do mass migration of VMs, so not just one at a time, and introduces some concepts as the plan, the mappings. So the mappings were already mentioned by Jakub, but this time we're large mapping of all possible networks and storages. So the idea is we leverage that, we do it once and for all, and then we do migration. And we also have migration analytics. I will come back to that aspect a bit later. So Konveyor's Forklift is actually, as you can see, a bunch of new custom resources. So we've got the network mapping, storage mapping, which are basically telling if my VM is connected to this network and the destination should be connected to that other network. So NIC by NIC, the conversion will be done. We also have the notion of provider. We have a source provider mainly, and also the target, but the target by default is created when you install the operator. And it's basically the credentials and the URL to connect to the provider. And of course, we've got the list of virtual machines we want to migrate. So from all those components, we create a plan. So the plan is basically the aggregations of, source and destination providers, the mappings, we're saying where everything is going, and 1 and 2 end virtual machines. So the machines we want to migrate together with the same parameters for migration. So, for example, when you create a plan, you can actually create, when you create a second plan, you can have different mappings as the first one. It's really up to you. You can reuse existing mappings or create a new one on the fly. Then, when we are ready, we create a migration. The migration is the instantiation of the plan for execution. So it will have all the status of the different VMs migrating. And if some of them are failing, the VM is you can actually restart the plan by creating another migration, and only the VMs that have not been migrated successfully will be migrated again. So this provides an easy way for retries. And from there, we're leveraging VMIO. Each VM, for each VM, we're going to create a VM import CR based on the mapping and information we have on the source VM. So from there, we delegate the work to VMIO. It's actually a layer of orchestration. We're trying to mainly focus on orchestration. The other part I mentioned is analytics. So as Jakob mentioned in one of his first slides, not all VMs are fit for KubeVirt now. So we know that some migration will fail, and we know it right away. We don't have to wait for the migration to fail. We know it from the parameters of the VM. So our first paradigm is one, don't block. The idea is to provide insights to the users, and they make the decision to run the migration anyway. So it may fail, but we want them. And the second idea is fail fast. So sometimes we know that there is absolutely no way for the VM to migrate. So even if the user has clicked on the migrate button, we can still fail really fast in the validation stage. So for that, what we wanted to have is an expandable and multi-level rule set. So the problems we may face may happen due to the VM configuration or the host or cluster configuration on the VMware side. So we want to be able to analyze many components of the VM, including its infrastructure. So what we also want to do is to use the concerns. So what we call concerns is a result of the analysis in many places. The first one is to expose that in the plan creation wizard. So graphically, you've got a UI for Konveyor, and in the UI, you will have the concerns for each VM of your plan. You can expand the list. We can show you that in a demo later. And you will know exactly why we are warning you. The second one is the validation is reflected in the plan condition. So if you're familiar with custom resources, when you reconcile, you can set condition on the VM. And actually, when we in the plan controller, what we do is we also ask the validation service for the concerns of all the VMs of the plan, and we will reflect that. So if something is red, or will fail absolutely, we reflect that in the plan condition. Just a way for the user to have a warning also after the creation of the plan. And we also do pre-migration analysis at scale. One difference with VMIO is that we have an inventory component. That is, when you create a provider, we create an inventory pod, and that inventory will actually ask the validation service for the concerns before you even create a plan. The idea is to get all the information as soon as we can, and because the inventory is live, it refreshes with any event from VMware. We can also refresh the concerns on the fly. And for that, we decided to use Open Policy Agent. So many people know it. There are many examples of using Open Policy Agent as an admission webhook. In our case, it's not completely an admission webhook. We're just as a warning, but not blocking. Anyway, it may become it may be considered as a valid admission webhook. Sorry. If you want to know more, we have a repo where we store all our rules. If you want to contribute to the rules also, feel free. It's working great, working in pod inside our operator. And now let me do a quick demo and see. Well, let me pause, slow it down. I think we still have a bit of time. Yeah, there we go. So here is the user interface of Forklift. You can see that you have an interface to create a provider. Here is a VMware provider. I enter all the credentials. And now that my VMware provider has been created, I have a tab with all the providers. And you can see my inventory is already running, giving me information about the VMs, the host, and everything. I can switch to creating a migration plan. I'm not super creative there. I call it demo. My source provider is the VMware provider I created, and I'm targeting a cluster named host. It is the cluster where the Kubernetes cluster where my operator is running. So directly, because we're already connected to it, we can get access to the cluster. Here is a way to select VM. I have multiple ways, folders. We also have a view with host and clusters, which is interesting. Here, I just want to show a few VMs, and you can see they all have warnings. It's a validation. From the list of VMs, I'm creating a new mapping. Only the networks used by the VM I selected are shown here, and that's the same for the net storage. So we are not asking you to map all the storages and networks at once. You can also do it plan by plan. And from there, you get the information about everything, a quick review, and we have our plan. We just click on Start. If we want to have more information, we can dig inside the plan and see what the status is. That lab is not super fast, so I had to cheat a little bit. But actually, you can see that the VM is migrated. We have a nice view of a pipeline with the steps. With that demo, we only had 2. We're adding steps at the moment for additional validations. Here, I'm just going to show you the Windows machine that was migrated. I always find it more significant to show Windows because I'm not super at ease with Windows. So if I was able to migrate it, I feel a bit more comfortable. I know Linux is going to migrate easily. And so you could see the VM has been migrated, and you just can use a UI for that. And I think it's all for me. No, don't restart. So we have a long roadmap for Konveyor using this quick summary. One of our main features is a warm migration where we're going to migrate the data before shutting down the VM. It's based on change bug tracking. People used to backup will be familiar with that. And it will allow us to reduce the downtime of the migration to 2, 3, maximum 5 minutes. I say maximum, it really depends on how much storage you have. Jakub, do you want to add another word about it?
As a summary, just to recap, we've shown you how to use virtual machine import operator to migrate your virtual machines one by one, from oVirt or VMware to Kubernetes. Then we show you Forklift, which can do all of that for you wholesale. And we're open for your questions.
I don't see questions in the chat.
So there are no questions here in the chat, but there were a couple of questions in so, oh wait, I see. I know. So there's a thread, by the way, in Slack where on hash virtualization where we can follow up on this session or any other. So Sachin there was asking if there are any experience or best practices on importing a Windows machine. And the comment is, I remember trying the import a while ago, especially for the Windows VM, and it took longer than expected. So basically looking for best practices on that.
We have the same experience of having Windows being longer than Linux. One of the reasons is the way the migration is done. Behind the scenes, we're using NBDKit or VirtV2V. Both are using the same pattern, but basically we're using the native VDDK protocol from VMware. What happens is NTFS is not reporting empty blocks the same way as Linux file systems. So basically, we have to. What happens is we transfer all the zeros, as well as the data. There has been some optimization recently, but it's not implemented yet in all the layers we use. So we will hopefully have better results. And we know it can be a matter of the version of VDDK, version of the vCenter API also. So many factors to consider there.
Okay, thanks. There was actually another question in Slack, just to be sure that, so Gregory asked it, just to make sure we understand. Konveyor is using managed VM and VM import, the Kubernetes operators that Jakub showed?
Yes. So Konveyor is the community we have, and Forklift is the tool. Forklift is actually leveraging VMIO. So the tool that Jakub explained, the operator, that the heavy lifting, it's VMIO and CDI. I also want to mention that because Jakub talked about it with data volumes. The heavy lifting is done there. And because it's working great, we are reusing it in Forklift. So Forklift is mainly an orchestration and analysis layer.
Okay. Those are all the questions I'm aware of. In any case, feel free to follow up with more questions or comments in hash virtualization in Slack.